Our first presenter is Mike Gretzinger. He's the research coordinator at Farming Smarter, and he's digging into a multi-year research project evaluating biostimulants.
So I'm going to start you off with a little monologue here tonight. Obviously, I've got Jimmy Kimmel muted. I don't know if you've ever seen where he does his little bits. They'll give a little segment on, the state of things in America and how silly people are and what they do and don't know. So we're going to play the same game. I went around the shop and I asked kind of everybody here, what is a biostimulant? So today we're going to play, what is a biostimulant?
No.
Hey, Caleb, what's a biostimulant?
A biostimulant is something that stimulates the natural process in a plant.
Right on.
Dang, hold on, man. I haven't even read it. Hold on, let me think. Hold on. Can we cut this and do it again?
Hey, what is a biostimulant?
What's a biostimulant? It stimulates growth. That would be my guess.
Ah, pretty good.
Drawing a blank. Jeez. I need books. Sorry. I am totally blank.
Aiden, what is a biostimulant?
A biostimulant is a chemical compound, oftentimes an inorganic compound that helps stimulate the growth of a plant.
So a biostimulant is something that stimulates a natural process in the plant. That's the simplest and most straightforward definition that I've come across. So what a biostimulant is, it's not a PGR. In fact, PGRs are basically an anti-biostimulant. They're regulating and stopping the growth of a plant. PGRs aren't fertilizer, and they're often confused with fertilizer. PGRs, biostimulants. Biostimulants are there to enhance the uptake of nutrients, and in fact, they often complement and correspond with a nutrient application to get the best bang for your buck, is the idea. So there's 5 main categories of biostimulants, and those are over on the right here. So one of the first ones that people hear about, I think, is hormones or seaweed extracts. So this includes things like auxins, cytokinins, gibberellins, abscisic acid, and ethylene, things that naturally occur in the plant. And now we're using that same thing to stimulate additional functions within the plant. Another one is biological. So just down at the bottom right there, symbiotic microorganisms, microbial inoculants, things that improve a symbiotic relationship or something like that could be considered a biostimulant. We've also got these fulvic and humic acids, as well as kind of tannins, lipids, lignins, and other things like that. So this humic acid is almost like a black chalk, and it's really long chain carbon source. And that's to function as a carbon source. You'll see a lot of like horticultural type applications for that. And then fulvic acid, so those are short chain, more honey colored compounds. We've also got this really strange one, protein hydrolysates, or amino acids and things like that. But protein hydrolysates are simply just enzymes that have had water added, and that's going to help them break down easier and going to help the plant bring them up a lot easier. And then the final thing there, I couldn't find a great picture, so I just got the green tea, but we're looking at plant extracts and more kind of concentrated plant extracts. So those are kind of the general categories of biostimulants, and most things should fall somewhere in that spectrum. So what are we talking about today? So my title is an unbiased look at biostimulants, and I was thinking about that when I put this together, and I figured I think I'm going to kind of roll with that unbiased and come up with some fun things around that kind of bias of research and bias of our own trials and thoughts, especially around kind of maybe a more loaded research application like biostimulants. I think it's a really good thing to think about. So I had to throw this in here. I just stumbled across it. I think somebody posted it up on Twitter. Sorry for not giving you credit, but we all have a bias of some kind. And so I'm just going to let this spray applications roll in the background. I'm going to go through a couple different biases that I think we see in these trials. So the first being a confirmation bias. Confirmation bias is seeing what we already believe. So if you're a diehard believer in micronutrients, biostimulants, foliar applications, doesn't matter what other kind of evidence to the contrary you might see, that's not really going to change your mind. And so That's especially challenging if maybe you come from a different region, or you've grown up farming a different way. You're always going to kind of have a certain bias, and that's just something to be aware of when we think about whether or not we're objectively looking at a certain data set. Another one is recency bias. This is something that just I came across recently, and this is seeing what we've most recently seen, and so kind of biasing things towards that. So 8-10 years ago, when I first started at Farming Smarter, we had a lot of wet weather, and now we're into maybe more a bit of a drought cycle in the last couple of years. And so if I look at the forecast now compared to 10 years ago, if I see a 70% chance of rain, 10 years ago I was like, oh, it's going to rain. And now I'm like, I don't really think it's going to rain. It hasn't changed. It's still 70% chance, but my bias of that has changed quite a bit recently. So we've also got primacy bias. This is kind of first impressions, and I think this could be a big thing if you're looking at a biostimulant for a first time. So this is one where we talk about it later, where maybe a farmer tries something out one year, it's a bad year, it's a drought year, the limits weren't there, environmental conditions weren't good, it didn't work, it's never going to try it again, right? Or maybe the opposite effect, maybe he tries it 2 or 3 times, maybe he gets lucky, maybe he had great conditions, and he's sworn by that for life. And he might be chasing that 50% yield boost he got one year for the rest of his career. So that's a bias to be aware of as well. Then we've got halo horns bias. So this is like looks, personality kind of thing. I think this is one definitely relevant to the biostimulant world. Oftentimes if a product makes things look great, we're going to like it. Whether or not it improves yield or not, it might just be big and robust and vigorous. It may darken something. There's that yellow flash in peas. If you can get rid of that, I mean, it's going to look better, and people are going to move towards that product. Even your salesman, who doesn't like a charming salesman, right? So we've also got centrality bias. So this is one that's interesting to kind of think about. This is coming across things where everything is kind of the average. And so this is one that I come across, doing observational ratings, herbicide ratings, vigor ratings, things like that, where it's like, nah, they're all kind of meh. And it's really tempting to just say, oh, everything's 85, 90%, whatever, everything's 5 out of 5, 4 out of 5. And this is why we tend to have really defined rating scales when we're doing ratings in the field, and to kind of pull apart this centrality bias and give more defined answers. So we've also got a leniency bias, and this is thinking that things are better than they are. So maybe there's a product we really like, or our buddy works there, or we work there, or whatever it is, and so we have this leniency to think, it didn't turn out whatever, but it's okay. It's going to turn out great, or it's really good. So leniency bias. I'm almost done, I promise. We also have similarity bias. So this is one where groups of people tend to clump together, and we kind of get these echo chambers of us versus them versus them, and it's really hard to take a different perspective. So this is one I've become quite aware of with maybe research versus industry versus sales versus whatever. Is that it's very easy to only pay attention to what's going on in your own little chamber there. We've also got idiosyncratic biases, and so this is where we know something is maybe deficient in our technique or our own system, and so as soon as something better comes along, we think, wow, it's way better. Even it might be marginally better, but because of our own downfall, we tend to rate something else a little bit better. And I think lastly, law of small numbers bias, and this one looks at kind of trials, location, years, etc. So it's very easy if we only look at data in Southern Alberta to come up with a judgment of biostimulants in general and say, well, I've only ever looked at data from Southern Alberta dryland sites on canola, and then therefore say this is exactly how they perform, or to say I maybe only look at specialty crops in these parts of the world in this areas and say, well, this is how they perform. And so it's kind of the law of small number bias. So we're going to pay attention to those a little bit. and just kind of keep them in the back of your mind as we go through some of this data, and maybe some, some of those epiphanies will kind of pop with some of the discussion here. So the goals today are to separate the facts versus the fiction on biostimulants and understand the biases that cloud our evaluation and kind of fair observation and assessment. And we're going to be looking at challenges and opportunities and how they fit into our cropping system. So why are we doing this in the first place? Well, back in 2013, there was some really big changes to the regulations. And essentially what happened was federally, we removed the efficacy requirements for a lot of new product registrations. Now, in all fairness, the market was pretty backlogged. We're talking 5 to 10 year timeframes to register a product that is already approved, 100 kilometers south of the border. You got 1,000-page reports. So a lot of this was done to allow innovation. It wasn't just like, let's see what Wild West, see what happens, but it was removing barriers to big products from other countries to use them on additional crops, things like that. And unfortunately, what that allows is a certain kind of less savory person to come in and try and make business. But truthfully, I think in our markets here, I think that sorts itself out very quickly. I think the reputable products are around, have been around since the beginning, and will be around because of they work. So what that did though was there was a lot of questions back in the early days of biostimulants, and so Canola Council put out this Ultimate Canola Challenge, and so there's a whole bunch of research groups that collected data for this. 17 sites, 17 locations. Where I just have straight yield data here from 2013, and really good data. And it tells us a couple things, but it's a little biased. And so I'm going to start with what it tells us. And so what this data tells us is that on average, we had 58, 59 bushels an acre canola in all our small plots, which is awesome. The only treatment effect we really saw was that reducing nitrogen dropped our yield a little bit. And you can get an ROI in that, and you may find that maybe we should drop our nitrogen a little bit. But in terms of these particular treatments, these were all new products that had popped into the marketplace at 17 locations randomly across the provinces, provinces in 2013, 2014. This is the averages that we got. So I say that it's biased a little bit because this is a shotgun approach. This is throwing every possible thing you can in there, seeing what happens, what works, what doesn't. And there's a few limiting factors that I think are important. So first thing I've come across, and I've kind of been going back to this a little bit, is the Liebig's law of the minimums. And so what this is saying is, is actually developed by Carl Sprenger, but later popularized by Liebig. And it states that growth is dictated not by total resources, but the scarcest resource. So it's really just a mathematical concept saying that the chain is only as strong as its weakest link. And this comes up over and over again, and it's a really fair critique, and I think it's got a lot of really good applications, but it's missing a couple of factors, especially when you consider kind of the advancements that we've seen in agriculture over the last 20 years. I don't think in a lot of cases we're necessarily at this point anymore, although we may be limited by acts of God or drought conditions or insect pest disease, things like that. But I think in a lot of the agronomic terms, we're doing a lot of things right. And so I think that's where we move into this Wallace's law of the maximum. And what that's saying is that once you correct for limiting factors, all the other effects get magnified, meaning that the sum ends up being greater than the whole of the individual parts. And there's some really good studies showing, maybe adding some potassium and some phosphorus might only add, say, 5 bushels an acre each, but in combination they might add 15. So it's not additive, it's not 10, it's actually 15 when you combine the two. And that's really cool. There's some really neat possibilities within that concept. And so I've got a quick clip here. I'm just going to throw in a shameless plug for our podcast project with Lethbridge College. I did one last week with Ryan Bonnet, Canadian Commercial Director at Solar Enterprises, and I got a couple little sound bites to throw in here. I think he did a really great job, kind of giving, just a candid look at biostimulants, where they work, where they don't work, what they're seeing, and kind of their strategy and approach to working with farmers. So let's have a peek at that.
Like, the question I ask any grower is, what other ideas do you have right now to help optimize and grow your, grow your crop as good as you can? Most guys are pretty damn good at fertility nowadays. I would say crop protection is getting fantastic as well too. Guys all know how to rotate groups. Fungicides, guys know those things, I would say pretty well. So what's the next thing that's going to get you that extra 2 or 3 bushel an acre? Because if you're not doing it, your neighbor competitor is, and you guys are both staring at that guy who's going to retire in 5 years and who's going to pick up his couple sections of land. So,
right.
What are you doing to optimize?
Right on. So what I'm really looking at here is that we're not taking a shotgun or reductionist type approach. We're looking for a win. When farmers have come to us and said, does this work? Should I go with this company? Should I do this? We've kind of stepped back and said, okay, well, let's do less of a very pure science approach to, study things in a particular setting, laboratory type style, does this affect this? And putting it out in the real world and saying, okay, we're going to grow this in a rotation. So now we're going to grow at 3 different locations: Southern Alberta, Battle River, and Sarda up in the Peace. So we've got 3 very different locations. We're running peas and canola and wheat all in simultaneous rotations. And then we're going to have products from ATP, Stoller, Alpine, Penergetic, an entire suite of products. So seed treatment, in-crop, fungicide, supplemental, and we're going to put that on the same plots year after year in rotation. And so now we've got kind of our best case scenario of that Wallace's law, that additive approach. So now we're looking, okay, over, instead of just like one shot, one thing, 1 year, does it work? We're going to have, okay, over 3 years, did it work in this crop? Did it work in this crop? Did it work better in year 2? Why did it work in year 2 and not year 1? We're going to have a lot more robust, but also complex and adaptive data set to work with. So it's really cool, the concept that we came up with, but it's also really challenging. It's just a shot of how the rotations are going to work. And we've got a picture here. This is me and Aiden getting the seed treatments and things set up last year, and some of the cool colors of all the in-crop applications. Then we've got a shot. This is our plots out just a couple weeks ago in Battle River, and this was their beautiful looking. This is rain-fed plots last year. Super impressive looking plots. This is a shot from last year I took. So this is another one of those observational type things. You're in here trying to assess whether some plots are better. I think the one we just passed is probably my favorite looking. There's a short trip there that we have to cut off. Does that affect, how you assess the rest of the plots there?
We are live. We're out here with Farming Smarter Live with Mike Gretzinger. Mike, what are we doing out here?
Well, we got the whole crew helping out today, or most of them anyways, and we're in the biostimulant plots checking out the biomass on the plots. So we're doing an above ground biomass, a below ground biomass, and obviously a total biomass. So when it comes to biostimulants, one of the things that we see quite a bit is improved vigor in the plants, as well as improved rooting, and those are lots of the claims put forward. And so we're digging these plants up. We're cleaning them off. You can see I got some peas here. We got really good nodulation, and we're gonna get a weight of 10 plants on each one of these, or 10 plants per plot on each one. We're gonna cut it at the above ground, below ground point. We're gonna clean the roots off really good, and then we're gonna get weights of each. So we're looking forward to seeing if we can get some quantitative data behind some of the observational data that we tend to see in the field. So.
Awesome. What are we using this data for?
Well, this is
so that's just a little intro on what we're doing with our biomass data. And we dug up some really cool things. So we've got, an observational piece, and where we've also got, this kind of cool shot. So this is just, we dug up plants. We want to see, is there an actual visual difference when we're doing the quantitative biomass weight. So I laid these out. I think I showed some of you these last year. This is our treatment. So we've got a check basically on either side, and the 4 middle treatments there are the company protocols or treatment lists that we have. And I think the 3rd and 4th kind of middle one there's a little more green robustness. We've got a little more root development, and so that's our visual there. And I also pulled out some canola. So the 2 end, far right, far left, those are our checks again, and then the 4 treatments in the middle. And so just kind of a cool visual. This was just random, and I'm impressed to see kind of an improvement in the root development and our vigor. So we do the same thing again this year. This is kind of our 2 shots at everything. And this is a look at our peas, and there's some really, really cool things to see. But of course, we can't just look at that and conclude whether or not something is better or worse. So we've got our pea biomass, and what we did was I actually combined for this chart pea, canola, and wheat. So there's no actual weight in grams. Everything's relative to the check. So the check is at 100%, and then everything is relative to that. So here in Lethbridge, I think it corresponds perfectly with the picture that we've seen, that treatment 1, 2, 3, 4 all had a higher percentage. This is actually above and below ground biomass that we're looking at here. So total plant biomass. But in terms of percentages, definitely higher. There's only one, site year, and this is where that, that recency bias maybe comes into play. So then if I add in there the biomass for Battle River and Sarda, which I don't have the awesome pictures of, you can see that it kind of falls back to 100%. It falls well within the error. And that's when we combine all 3 locations for 2020. It actually, in fact, numerically dips down in a couple places. And so I think, their individual sites might have looked worse than ours. And there's some digging to do in terms of, environmental conditions, and some differences in the applications and things like that. So a lot of cool, interesting things to look at, but I am happy that our visuals matched up with our observational data in this case. Small plot and field scale trials, and I hear that a lot. I'm just wondering if you can give some specific examples of things that you've seen, or just where that happens, because I've heard it repeated over and over, but I don't quite know why that is or what that means specifically.
Yeah, so I mean, from my past life working with other companies, I mean, you can exactly hone in on like an environmental or climate condition in a lab, and you can spray it exactly perfectly, exactly right, and you've got a lot of control over what's happening to that plant. Whereas, like, when you get into a field scale trial, let's say, for example, if you're a farmer, you've got a 60-foot boom or whatever it is, you have different spray nozzles, you have different like spray rates, your weather's all over the place. You just can't control those variables as well as you can in the lab. So products need to be more robust and need to have a better efficacy out there than they might need to in a lab. That'd be kind of my take on it if I had to put it in my own terms.
So like I said, I had a really great chat with Ryan about some different things regarding biostimulants, and I'm going to show you. This is atypical for me to go out into the field, so I had a lot of fun, and thanks to the guys for showing me around. We went out and looked at some biostimulant strip trials out at Ryan's place, just south of town, and I've got a short little clip on here on what we did.
Hi, it's Mike at Farming Smarter. I don't even recognize myself here. I'm in the middle of an actual field instead of the small plot. So with all the murder mystery stuff going on social media, we got a little mystery of our own. We've got a bunch of different treatments flagged out beside us, and this is a field scale trial. So We're looking at some different biostimulant seed treatments. There's an untreated check hidden somewhere. There's a number of different combinations and formulations of seed treatment. We're gonna go dig up some plants and check out some roots, wash them up and kind of see what we can figure out. So the two gents in the background there, I think they're probably trying to discuss where they're gonna dig things up. You can follow me along. We'll see how this goes. This should be lots of fun.
So we went out, dug up some plants. I had a look at a few different things. Funny enough, looking back now, I can see a few other biases maybe coming up that I never even thought of. And this is where that the bias to think that, want to say that everything's close, even though you maybe know that it's not, just because you don't want to get something wrong. So I went here pretty blind, not knowing which treatments were going to be which. After looking at the first to the second, I knew there was a big difference, but you're really kind of nervous to be like, oh, for sure, this is whatever's on here is magic and great. You don't really want to say that and get it wrong, right? And embarrass yourself. So yeah, definitely had a lot of fun out here checking this out. So we sized everything up. Again, kind of nothing too scientific here, to be honest. We just took a kind of uniform looking section of the ground and said, okay, let's compare this one to this one to this one, and rinsed everything off, lined it up, took a picture.
Well, mystery has been solved. I guess the untreated check. I didn't know what the other treatments were in the spring wheat field, but we definitely saw a lot less root growth on those. So that's pretty interesting. We're here in the peas now. This is a dryland pea field, and it has been pretty dry, so pretty limited nodulation. But I am impressed how long and developed those roots are. It's a lot like a tree, like they say, for how much mass you have above the soil, you're probably going to get just as much below the soil. A little different side-by-side comparison. There was no check to pick out here, so just looking at competing seed treatments. So I'm on the fence on this pea field here, but really cool to get out of the office and be in a real field and see some of the going-ons and a lot of big differences between the small plot research and the field scale. So a lot of different things to appreciate there. Thanks a lot.
All right, so just to prove to you, that I knew what I was doing and I solved my mystery, I've got all 4 of the samples in order here. I dug up obviously the far left-hand side there, didn't really know how things were going to compare from there. So I said, after I dug up the second one, I said, okay, that first one's got to be the check. So there's our first one. Wasn't quite sure, got to the third, fourth, said, okay, one of these is commercial. Third one, I assumed was, because it had some red on it. I'm a good detective. So that's our commercial only. And then our commercial petargetic in each of these. So I was pretty impressed with my detective skills here. I think I did pretty well. And I think in this case, I'm seeing some cool things. So here's a shot of the field. This is an interesting one. This is a strip trial of peas. And so this was actually comparing 2 competitors. And I don't actually know which one is which in this case. It's just as we were getting ready to leave and go have some dinner. And kind of just did that, eyeball down the field and went, wow, like I see a difference here. And you kind of, well, no, maybe not. And then you go up a little further, you go, I definitely see a difference here. And then maybe, well, maybe not. And so there's a definite bias there. But it is interesting, and it's one of those things, there's this really marginal area here on the right-hand side, and there's this really, a lot better looking area. And this just kind of speaks to that challenge of field scale work and field scale trials. I think if there's anything like this in a small plot, it'd probably get flushed out through having our randomized strips and reps. Whereas in a field, if you just stand in the wrong spot, you're going to see the wrong thing. And so there's a challenge. And so when I jump up ahead, all of a sudden that red line down the middle, maybe not quite as much. And so it's harder to say, which one definitively is better or not. Although personally, I still have a lenience towards one side. So one more clip here. So I guess the only challenge that usually comes up, or that comes across our our neck of the woods is farmers just want to know ROI. And so they say their criticism is like, well, if it doesn't show up in my yield monitor, I can't tell, like it's not worth the extra buck. So what do you say to that? Like, what's your thought there?
Yeah, and I would just ask them, like, how are you monitoring that ROI? Because if it's just a yield monitor and you're just visually looking at it, okay. But I would ask you too, like, are you actually pulling out the data and seeing, like, hey, maybe it's 2.1 on this one this year, but maybe it's 6.2 the next year. Each year has got its different variabilities there that can fit in there. But like the ROI comment, very, very fair. And there are times that it absolutely does come out with an ROI, and there's sometimes because of the weather, it's really tough to. Like I'll tell you what, nothing had an ROI in Southern Alberta in 18 and 19. Like it was just dry.
Our dry land stuff was junk. 20 bushel canola was looking nice.
Yeah, like there's nothing, there's nothing we can do there. But last year, like we were seeing some fantastic ROIs, some 3 or 4 bushel an acre on canola, some 6 even on some of our trials in Manitoba. And some people will say, well, 3 bushel an acre isn't enough. And I say, well, 3 bushel an acre at $15 a bushel, my product is 11. Like you're getting a 4, you're getting a 4 to 1 on that one. I would put my money into a 4 to 1, like a 4 to 1 return. Like, tell me where I can get that investment.
Yeah. Just realized there's a different Ryan's field, by the way, not this Ryan. But the almighty yield, the almighty ROI. So how have things turned out so far? Well, I'm looking at canola yield here, and this is presented again as percentage of our traditional. That's because we're combining data from Lethbridge, Battle River, and Sarda, and with the kind of differences in our yield, it made it a little challenging. So we just normalized everything to 100%, which in this case was 85 bushels an acre, which is a quite reasonable canola yield under small plots. And we've got N equals 12, not quite significant. It looks like there's a little bit of noise still there in the data, maybe a treatment that's increasing yield for that year in the 3 locations. And very interesting to see what will happen when we combine this year and of course year 3 on there as well. Looking at wheat yield, same thing. So this is our 100% was 71 bushels an acre. And we're looking at wheat yield in Lethbridge, Battle River, and Sarda. Nothing really jumps out. I mean, you can see treatment 1, the error is enormous there. So in some cases, we saw a huge yield advantage. In other cases, not as much. And so that's where getting more quality data is going to be very interesting to see what we can do with it. And then P yield's a little strange here. So this is our Lethbridge, Battle River, and Sarda. This is where or maybe our bias and our other things, we really got to kind of check ourselves at the door. I don't like to show the Battle River data because there's something so extremely good about all of their treatments that it's hard to believe that it happened. And we're still kind of investigating why some of those numbers are so high. So in fact, took that out. And you can see in the P's a little bit of potential there. So this is Lethbridge, only Lethbridge and Sarda, but between 110 up to almost 120% of the traditional. So if you're looking at ROI, a 10% yield bump, you look at 5% rule, that's 10% is better than the 5% rule. And I think like we kind of said before, when the agronomy is good and all these other things are good, what else do you have to look at? And I think some of this may play in there. So it's very cool. I'm going to leave you with maybe one last little clip here. You have to be ready to be like, or at least kind of have a plan in place to say like, okay, if things get real hot, I'm probably going to put this down. And it's just kind of one more thing to add in. So
nice. Yeah, it's almost like an algorithm. If this, then that.
Yeah, that's kind of what I was thinking.
If this, then that type of thing. And like there's a lot of those type of things that can fall into this biostimulant world. But most guys, and this is, and I think farmers would even say this, is like, well, it didn't work last year, I don't want to try it this year. Or that worked great last year, I'm going to do it every single year, whereas you absolutely shouldn't. It is easy to fall into that trap. We're all like that. Exactly. Like we're all into that. Like,
Okay. So I got to say, I'm really impressed. Check out the podcast when you get a chance. I'm really happy with the engagement on this trial from industry, from farmers, from really everyone. You know, it's been no small task. There's a bit of a balancing act, you know, to service kind of two domains in that regard. And I think, you know, when it comes to this trial, there's some things that we're seeing. So, you know, field scale versus small plot, it's tricky and it's different, but, you know, I want to see results in both. Goof that. And, you know, we kind of got to check those biases and think, you know, as much as we like to think we're being objective, I think a lot of times we're not. And there's a challenge there, especially when looking at a new product like this or a new suite, and just like, you know, how do you set up the trial? What kind of design are you doing? Are you doing field scale? Are you doing strip trials? Are you doing, you know, one versus another? Are you putting a check in? You know, there's a lot more to that. And unfortunately, you know, maybe you came to this presentation hoping it has some really good definitive answers on, you know, should you use a biostimulant? Here's when exactly. I think that's maybe a few years away for us when this trial wraps up. I'm hoping to have, you know, Grabir's really great at putting these data sets together and kind of flushing out some of that nuance. And so hopefully in 2 or 3 years, we'll have a really good, you know, better recommendation type strategy for these things. But right now, honestly, I feel like sometimes there's more questions than answers, and hopefully the more aware we are of how we see those things, we can become a little bit smarter that way. So thanks a lot for listening, and I'm here for some questions.
All right. Thanks, Mike, for that fantastic presentation. As he said, he is available for questions. So I encourage all of you to turn on your cameras if you want to ask the question yourself. You can raise your hand, or you can just type questions into the chat. I guess to start off with, Mike, I really liked the way you looked at biases. Do you think that there are you know, people's opinions would change if they could recognize their biases, or are people so set in their ways that it's just inevitable?
Well, you know, I kind of got off on that tangent a little bit. You hear me okay? Yeah, I got off on that tangent when I was looking through the title and kind of, you know, setting up the presentation. And I think, yeah, for your question, I think the first step is just to recognize our biases. And so when I started looking at, you know, what are some of the biases that I could show and maybe pop into some of our research, I was like, holy smokes, like I'm guilty of almost all of these in different forms. So, and that was just a small segment. I think I just found a top 10 list of maybe different biases that people have. I'm sure there's hundreds of different biases that we have. So I think, you know, recognizing, you know, when it comes to certain things, how are we being, and just, you know, being clear and upfront about, you know, maybe what our perspective is or what our, you know, vision is for what we're trying to do. And so, you know, when it comes to this trial, that's why I've tried to be very clear. You know, we're taking that approach where we're trying to put like a whole program together. We've got a rotational study. Like we're looking for that kind of compounding effect, or like kind of effect where things are better than just individually. And so that's kind of the bias of this trial. And I think, you know, with other stuff that we've done, they're biased in other ways. And you know, also recognizing, you know, we're in dryland southern Alberta for a lot of our stuff. So I'm definitely biased against, you know, micronutrients and other things, because in a lot of our certain cropping situations, it's not the same as other parts of the province or other areas, or the intensive irrigation type side either. So yeah.
Scott, did you have a question that you wanted to ask? You're on mute there, Scott. Still on mute. Can't hear you.
Still on mute. Okay.
Hey, yeah.
Hey. I had just put on the camera because you had said to put on your cameras, so I thought I'd just turn it on. But
Oh, I'm so glad you listened.
well, you know, I'm excited to see what the final results are on this, because it'll be interesting to see kind of, or where specific opportunities are to use them. But it's interesting to see it work.
Yeah, and I think that's kind of an important part of this trial, is that I don't expect it to come out and say, here's all the great things that are happening here, 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 here. I think it's going to be we're going to have to do some of that going, okay, well, in this year, we saw really good things at these two locations. And this year, canola, this is what we saw, and this year, whatever. And you know, just like my conversation with Ryan, I think there's times in a place where some of these things are going to work, and then there's times in a place where it's like, this is where it's going to work. And that was part of the conversation we had too, was, you know, developing kind of a flow chart. And so I challenged him. I said, like you guys need a flow chart. You need like a, you know, are you growing? What crop are you growing, right? And then like, you know, is it irrigated or dry land? And what part of the province, and what this? And then, you know, you kind of develop an algorithm for saying, okay, well, here's my plan now. And that was one of the biggest challenges of coming up with this protocol. Was, I think, you know, Ken had come up with a protocol 3-4 years ago and submitted it. And, you know, then every year we kind of resubmit, and we'd have to adjust the treatments. And sometimes the companies would adjust their product offerings, and then they, you know, a new recommendation would come along, or they'd say, you know what, we think this is a better product than this one because it's got a different formulation. And so there's a lot of like challenges that way to keeping up with it. And so it's never going to be perfect, but I think having some sort of, you know, algorithm or, you know, kind of flow chart for how you want to do this is a good way to go about it.
Mm-hmm.
All right, if nobody else has a question, I'll ask another one here for you, Mike. You were talking about the law of small number bias. And, you know, oftentimes, especially for us, you know, we look at the Southern Alberta focus and what is going on that could be relevant here. So does that play in our favor, or is there a flaw perhaps in our thoughts there?
Well, yeah, I mean, it's kind of that law of small number bias. So that's where, like, say for example, you know, you've got a team of people in your office, and you're you know, evaluating one really high achiever versus the other ones, and you don't realize that, you know, your office is the best out of all of Western Canada or the world or whatever it is. You're biased based on those particular people that you have, right? So I think small number bias when it comes to research is kind of the same. So we could be, like you said, biased towards things only in Southern Alberta, and not realizing, you know, maybe how good our agronomy is, or just how good our nutrient management is. And, you know, we've been doing things like zero till for a long time in our, you know, dryland crops. And, you know, remember we took a trip south of the border, and no offense to anyone down there, but it was kind of going backwards in time in terms of like some of the cropping practices. There was still wheat fallow, you know, south of the border when we went on our trip. And, you know, I think it's easy to look at, you know, our very specific things, but when you take that bigger perspective, you kind of get a, I guess, better perspective of where we're at overall.
Okay, there's a question in the chat here from Lee, and he's asking for the take-home message for farmers.
What's the take home, Lee Hart? Okay, well, yeah, obviously I want you to wait for the results, but even then, I think a take home message is just to think about, you know, obviously everybody's situation is going to be different. So like I said, you know, and even in our conversation before, like, you know, the recommendations are going to be different for every farmer, for every, you know, different crop that they might be doing, and for every condition. And just pay attention, you know, if, you know, recognize that if you tried something in 2018, 2019 and it didn't work, it probably wasn't the product's fault. And, you know, if you've been doing, you know, something for 4, 5, 6 years under great conditions under irrigation and it's not working, well, then maybe it's time to rethink what you're doing. And so I think, you know, I can't give you the definitive this works, this doesn't work right now, but I think a really important perspective is just to look at, you know, your overall conditions and your overall situation, and make an evaluation based on that. I'm waiting. Anything else?
Nobody else has a question for Mike? Okay, I guess I'll ask one more then. When you looked at your data, it looked like there might be more of a potential in obviously certain crops. Is that a trend that you could see? Is that maybe certain crops could be more responsive to different products or product lines or the systems approach?
Well, I don't know that that's specifically the case. I mean, there's probably some other people listening that might know better whether certain crops around here are more or less responsive. You know, I think in the case of the cereals, I don't know that maybe, you know, going back to some of the, you know, the law of the minimum and things like that, you know, we're relying on rain-fed sites at Vegreville and Sarda, and we've got kind of a semi-irrigated site here in Lethbridge, so potentially there's just some of those crops didn't meet those thresholds. We've also, you know, I think yeah, maybe some crops are more responsive. I'm maybe not the best to answer which those are. So if somebody else can help me out, if you're listening, if I think from the conversations I've had with some of the other guys, I think they did think that peas had a little more potential maybe, or they were seeing some things in last year, the last couple of years. Maybe there's a recency bias there, I guess, but maybe somebody else can come to my rescue on that one. I'm looking at Scott because I can see his video.
Okay, well, I think we'll wrap it up. Mike, thanks so much for your presentation. I thoroughly enjoyed it, and I'm sure everyone else did as well. I will share the QR code for this session for those of you that are going to get your CCA credits. You can scan the QR code with your phone, or like I said, you can type it in the chat if you don't have the app and would like me to submit on your behalf. I will take a short break and we will come back right at the top of the hour at 10 o'clock. So by all means, fill your coffee, grab something to drink, hit the washroom, and we will start back again at 10 o'clock.